The symbolic engine in PTC Mathcad allows users to represent their results explicitly and symbolically. In this first example, we have an object in free fall with negative g acceleration. We can numerically define velocity and position as functions of time through either manual integration or the use of the integral function. We can compute the velocities and positions at any given time. The constant acceleration leads to a linear velocity and a parabolic position. In contrast, evaluating symbolically returns negative g instead of a number. We can do the same with the integrals. Integrate a symbolically and assign the result to a function v of t, and integrate again to get position y of t. Let's plot the integrated function v and y, change the acceleration, and see new results. Let's move on to a more complex example, the classic mass spring damper system under an external force. We wish to determine the position of the mass. We can run this numerically with an ODE solver, but let's try to determine the result explicitly. We first take the Laplace transform of the force, assign the symbolic result to a function f of s, which represents the force in the frequency domain. We transform the whole equation of motion into the s domain. We solve for the position x and then expand the denominator into a polynomial, all done with keywords. Finally, we take an inverse Laplace to get us back into the time domain. Changing the mass, damping, or stiffness coefficient gives us new position plots. Redefine the external force and get new force and position plots. Using symbolic math lets users not only express results explicitly, but to also go between symbolic and numerical calculation, letting them determine the representation that best suits their needs.